Okay, hello everyone. My name is Kejin. I'm from Department of Geography. I'm a third-year PhD student in Department of Geography. Today I want to talk about the ontology of geographic representation. This is also the field which I am interested in GI science. So I will, in GIS, we don't distinguish between the term of geographic representation and spatial data model. We think these two terms are the same term. And I also call this term OGR for short. I will use this term in my paper for short. Okay, this is the introduction part. These are the existing research on spatial data models. First, we have the definition of field and object spatial data model. And then we have a new achievement in 2007. We define a primitive element, geo-atom. And then we can use geo-atom to integrate field and object model. And then these four papers, there are some achievements. They provide different methods to describe the characteristics of field and object representation and describe their relationships. But for this achievement, I think they are not using ontology to describe their relationship. So I think ontological analysis to analyze object and field and their relation. This is a new field which needs to be discovered. Okay, this is the existing research from geographic ontology. So we have existing research to analyze geographic category and different landforms, like if mountain exists. And then we have ontological analysis for topography. So this is the existing research on geographic ontology, but it is also necessary for geographic ontology to include object and field geographic representation. So this is the technical part of this research. For existing research, they use UML, United Modeling Language, to describe object and field. And the left picture is the UML description of field model, and the right picture is UML description of object model. So you may be familiar with UML model. This is a tool in semantics analysis. In UML, we describe the relation between classes using cardinal relation. So in this picture, we can see the relation between classes can be described as one-to-one relation, or M-to-N, or one-to-N relation. So when we say UML model, we only refer to class diagram. So this is class diagram of field and object model. But you can see UML also have some limitations. As a semantic tool, ontology can be used to enhance the power of this model. There's not only like one-to-one or one-to-n relation. We can also use ontology to describe some more kind of relation to describe more information. Okay. When we talk about geographic representation, first we need to talk about the dichotomy between field and object representation. So when I think about field and object, this is the first picture I think about. This is also the exam professor taught us in our first class. This is Albert's grid model. When we create ontology, it is just like when we look at the world using this grid structure, and then the size of this grid structure will mean the granularity of ontology. If the grid size of this structure is smaller, indicating there are more details in our ontology. So in ontology, we have the concept of granularity. Also in geography, we have a similar term. We call it scale. So in this structure, we call it a spatial scale. Okay. Also, you also made me think about some other examples. For example, in GIS data products. In many cases, the first kind of GIS information products is raster data, or this is a type of field model. In many cases, the first product should be a picture of a remote sensing image or a picture of a scanned map. When people look at these pictures, their first view is like this grid structure, like a matrix of 1000 times 1000 with different colors in each cell on the map. And then people can use their eyes to distinguish on the picture to figure out there are many countries with different colors. There are many geographic objects on this map. This is also an example on field and object. We can see this is a dichotomy of two types of spatial cognition. So when we look at this picture, for a machine, when the machine look at this picture, this is only a picture with a matrix of maybe 2000 times 1000 with different colors on that. Some of the colors is red, some of the colors are green, some of the colors are gray and black. And then people can use their eyes to figure out this is pillar, and this is computer, this is desk, this is blackboard. So people can use their eyes to process from field representation to object representation. From object perspective, we look at the picture and we can figure out this is pillar, this is computer, this is text. So this is object viewed of spatial cognition. Also, in GIS, there are also addressing resource field. We call it sensor network in indoor environment analysis. So we can put some sensors in this room, and then sensors can figure out the information of different objects in this picture. For a sensor, the first information of a sensor should be a picture like this, and then a sensor can also get the information of different cell, the distance between each cells to the sensor, and then sensor can figure out this is pillar, this is computer. So we can see in this example, sensor play similar function as human eyes. Okay, so this is a computer representation of field and object models. When we look at New York State map, the left-hand side is continuous representation of New York State. So this is field model. And the right-hand side is discrete representation of New York State. We use line, polygons, and point to represent different objects on the map. And then next job, we need to figure out the relation between some major terms and BFO. So this is the general structure of BFO. You're all familiar with that. So in this structure, something need to be figured out first. We have the concept of object in BFO. So for object, it is a type of material entity. But in this ontology of geographic representation, OGR, we also have the definition of object. This is different from object in BFO. I need to talk about it later. Also, in another case, we have an object term in object-oriented representation. you are familiar with that in software engineering, object-oriented representation. In that OO representation, we think about each entity in the world as one object, and then we implement them in the software. So object in OO representation is also different from object in this material entity in BFO. We have the term of field. Field in geographic representation is also different from field in physics. For example, in the world, many geographic phenomena can be represented by a field like air pressure, precipitation, temperature, that could be represented as a physics field. For a physics field, it should be categorized under a material entity, and it should be an object here. Yes. Also, it's different from a field in geographic representation. So this is two debates in OGR. First, we have the debates between object and field. For the debates, object and field, there are two types of spatial cognition. There are the two dichotomy idea of spatial cognition. So I think it should be categorized as entity continuant, independent continuant. In material entity, it should be a type of spatial region, because this is an abstract representation of spatial region. And then we also have a debate between vector and raster. For a vector, this is a mathematical representation of object, like we use polygon to describe different countries, we use lines to describe road data, we use point to describe city data. So point, line, and polygons, they are mathematical representation of object. We have a name vector to describe that. Also, we have raster. Raster is a grid structure of field. We use a matrix to describe field, like 100 times 100. So vector and raster, they are mathematical model to describe object and field. So they should have the same placement as software and dramatic art. So it should be categorized under entity, continuant, dependent continuant, and generically dependent continuant. So it's just like a piece of dramatic art. It can be implemented in the computer. You should have patterns. So it should be a generically dependent continuant. So this is the first concept for the ontology of geographic representation, geo-atoms. For geo-atoms, according to the definition of Goodchild, we have a point x indicating the coordinate of a geographic point, and then we have its property, like precipitation, and then we have its value. These three elements are the basic elements to describe a geo-atom. So using this geo-atom, we can see like the temperature of Buffalo City is 50 Fahrenheit. So in this case, we have a point indicating the coordinate of Buffalo. We have a property temperature. We have the value 50 Fahrenheit. Next is the definition of geo-field. A geo-field is an aggregation of geo-atoms using the same property. So we can create a different type of field, like precipitation field, temperature field, or air pressure field. We can define using a specific property. And then we have different types of field here, from F1 to F6. This is an example of geo-fields from F1 to F6. Due to the time limit, I will not explain these categories. I can say from F1 to F3, they are the same major category, and F4 and F5 are the same category, and F6 itself is one category. And then this is geo-object. So we have 4 basic elements to describe the geo-object. Point, line, area, spatial, temporal object. For geo-object, it is an aggregation of geo-atoms using a range of the value here. For example, we can when we describe our campus, we can specify the value of the name of a building as electrical complex or park hall, and then we can have a polygon representation of a building. Also, we can define an object using a range of temperature or a range of precipitation, and then we can have a polygon of an area of a precipitation. And then based on these 3 criteria, we can categorize geo-object, and then we can have a cubic structure of object. These are 3 categories here. If it is movement, if it is moving or stationary, if it is dynamic or static, if it is evolving or rigid. And this is the cubic structure. Based on these 3 criteria, we can categorize geo-objects into 8 categories. Based on its geometric condition, based on its internal structure, and based on if it itself is moving or not. And then we also have existing achievement to describe the relation between object and field. The first one is object-based field. It has a matching method to match a field with its corresponding object. And then we can use this kind of matching model to describe some model in wheel-shape analysis. And then we also have a field-based object. So it can represent the internal variation of the property Z in the geographic object. So we can use this kind of model to describe some moving objects like hurricane or wildfire. So this is the general structure of OGR. First, we have the ontology of data models. It should be categorized under spatial region. And then we have the ontology of geographic entities. They should be in the category of objects in material entity. And then we have geographic events. It should be under occurrent. It should be a type of process to describe event, process, and state. And we link a geographic entity and its data model using a new relation. It's represented by. And then we can use this relation to describe it. And then this is an example to show a hurricane process from state to its event, its process. Next is my next plan. We can create an ontology of agent-based modeling to describe agent-based model, describe the relation between agent, organization, agent and its environment, and organization and the phenomena. And then we can also enlarge our ontology using ontology to describe agent-based modeling and its spatial data models. So this is a simplified model. We assume that the environment is a kind of geo-field. We also assume that agent is a kind of geo-object. So this is my future work. I plan to design a category of methodology to integrate agent-based modeling and geographic representation and ontology. My major interest is the computational part of ontology. I like the ontology if it can be understood by a computer. So my future research will be on this area. In this presentation, I have some work in this area and some of work in this area. In the future, I will focus on this area to describe the relation between agent-based modeling and ontology. My future dream will be converting the interaction between agents into the process of reasoning. Okay, this is also the future work describe agent-based modeling and its geographic representation. So this presentation is only our initial work. For the future, I need to think more about this to answer these questions like how an agent's behavior will affect its characteristics of geographic representation, and how the interaction between two agents will affect the interaction between corresponding data models, and how this relationship can change the result of geographic process analysis. Okay, this is my presentation. Thank you for listening. Any questions?
Have you thought about the spatial scale in your ontology? Because as you mentioned at the beginning about the scale, the spatial scale, the granularity, is very important, the component for the geographic representation. So based on the spatial scale, the field, the representation way of the field or the object will be changed. So in your ontology, I'm just still wondering there is the scale in your ontology or not.
Actually, this is a big question. What we know in ontology, we have the concept of granularity. In geography, we have the question of scale problem. Geographic phenomena can be seen differently in different scale. So we can also try to use ontology to describe these different kind of results in different scales. Yeah, this is a good question in the future. But at this stage, this is a future work to be done.